Did you ever have a plant that was so unique or so exquisite that you wished you had hundreds or thousands of them to enjoy or to sell? Plant tissue culture is a technique which will do just that for you. Plant tissue culture refers to a method of multiplying plants from very small parts of the plant, such as buds, nodes, leaf segments, root segments, etc., in a controlled environment. Gottfried Herbertant conceived the whole idea of tissue culture in 1902. His idea was based on the concept of totipotency.
Totipotency means a cell given the proper condition and the proper nutrition has the capability to regenerate into a full plant. That's why the tissue culture is basically based on that principle. So totipotency is the main thing. So for that reason now people are doing tissue culture from single cell or a group of tissues, organs, or any part of the plant. So you can do it, you can take it and do it. In nature, we are doing this vegetative propagation or seed germination. But here what happens is that in seed germination you are getting one single plant. And then even vegetative propagation, that also if you cut a stem and put you get one plant, that is limited. But in this tissue culture, as I said, that totipotency, because of the basic principle behind that. So if we take a small piece of cell, which a tissue, which contains say few thousands of cells or few hundreds of cells, but when you are given the proper condition and the environment and the hormone from externally, it triggered the cell to regenerate. And then from that small tissue, you get thousands of plants, you can be able to get it. That is the advantage of this tissue culture. But mind, one must remember that these are all done under control and this aseptic condition, not in an ordinary environment like that. That is the main thing.
Tissue culture is an alternative to more conventional methods of plant propagation. The problems that were thought as insolvable by conventional technique can be solved using this technique. These items are required for tissue culture. Tissue culture laboratory, distillation unit, pH meter, weighing machine, autoclave, laminar flow unit, culture rooms, instruments like scalpel, forceps, cutting knife, etc., and a refrigerator.
If you're not doing research and development, you need not have so many equipments. You need only just a minimum, that basic requirement. What you need is one distillation unit to get distilled water, double distilled water. But that also, if you cannot afford, what we do is you can buy from the distilled water that from the shop also. That also serves your purpose. But that is not a double distilled water. Mostly that is a single distilled water. But still then that also it work. But that's why distillation unit, which goes depends on the type of distillation unit you are buying. So, but it is not very costly.
This is a double distillation unit. The tap water enters through this pipe. When water starts boiling, the vapor rises up and passes through this pipe to the second distillation unit. This is the second distillation unit, where the same principle is applied. pH is an important concept. It is a figure expressing how acidic or alkaline a substance is. 7 is neutral. The lower the values, the more acidic is the substance, and the higher the values, the substance is more alkaline. P represents the German term Potenz, which means power. H represents hydrogen. The pH meter measures the hydrogen ion concentration. In tissue culture, 5.8 pH is usually maintained, but it varies from species to species. This is a pH meter. Let's analyze this water. Its pH is 4.56. It is acidic. To increase this pH level, sodium hydroxide is added and stirred. Now the pH is 7. Nowadays, pH tablets are available in the market. This weighing machine is capable of weighing very small quantities.
When you're using growth hormone for your culture media, hormones you require very minute quantities. You don't use in gram or like that. We use in milligrams. 1 milligram, 2 milligram, sometimes even 0.5 milligram like that. For that reason, you need accurate balance which can take very minute quantities also. Otherwise, others you cannot take 1 gram also because that may be the lowest unit like that. So that is why it is. This is very useful. You just put the paper first. Different chemical, both inorganic and organic, the vitamins, then this hormones, few hormones are required. So that those are the things which you require to buy. But for chemicals or this thing, nowadays you can get the ready-made packets also. You don't have to buy all these chemicals because if you buy that, it may cost you a few thousand rupees for buying different chemicals. But nowadays there are in the laboratory supplies, even ready-made packets like this molasses goods, white medium, this Western and then all these are the culture media, different type of culture media. And there, what you do is that they have given the instruction on the packet that for 1 liter, to prepare 1 liter of media, you pour this much gram of that powder, that which is already mixed and kept. All the nutrients are mixed and kept there. So there you don't have to have you don't have to do all measurement, this or that, like when you are buying different chemicals. So you can just pour the thing inside and mix it in hot water, dissolve it like that, and you can do it, prepare the media. If you are not doing that, you have to buy the different chemicals, and there for that you need a good balance again, because here you have to weigh out 10 grams, not 10 grams, 10 milligrams, or sometimes 20 milligrams, or sometimes even 1 milligram, very minor quantity, which is very difficult to get from a ordinary balance. So you need to have a good this electronic balance or electrical balance, which is like that. That's why for a layman or for a person who wants to do, if he cannot afford to go for all the things, the best thing is buy ready-made media. Nowadays is quite easily available. These are the different
These are the chemicals for preparing the media. It is always advisable to prepare the chemicals and keep them as stock solution in a refrigerator. Of course, growth hormones and vitamins should also be stored. The stock solution must be properly labeled. When the stock solution is taken out from the fridge, it should be brought to room temperature. The basic components of any culture medium are macronutrients, nitrogen, potassium, phosphorus, calcium, magnesium, and sulfur. Micronutrients: iron, manganese, zinc, boron, copper, molybdenum, cobalt, and iodine. A carbon source: the carbohydrates usually used are sucrose and glucose. Vitamins: they are thiamine, nicotinic acid, pyridoxine, and myoinositol. Growth regulators: both auxins and cytokinins. Solidifying or gelling agents: the two commonly used are agar and phytogel. There are two types of media. One is semi-solid media and the other is solid media. After putting the media in the test tube or flask, it should be properly sealed with aluminium foil. This is an autoclave.
Here,
It is used to sterilize all the necessary equipment and media.
that's only.
The autoclave should be filled with water and covered with a tray. Then all the items are kept for sterilization.
So
Make sure to open this knob to release the air, which is already trapped inside the autoclave. When the autoclave whistles, tighten this knob to create a vacuum inside the autoclave. When the indicator reaches the sterilization zone, the temperature inside the autoclave is very high, which kills all the germs. The autoclave should be kept boiling for about 15 to 20 minutes, even in the sterilization zone. The autoclave should be opened only when the indicator falls to 0 degree.
the pressure is so much.
This is the correct way to open the lid. This M-shaped paper is called a paper bridge. On the top of the paper, the plant is grown. This prevents the plant from suffocation. Autoclave is not the only solution for sterilization. There is an alternative.
Pressure cooker is itself same thing as basic principle is same as this autoclave. There you cannot put so many equipment, or so you cannot prepare media maybe in large quantity. Only, but if you have a like 5-liter pressure cooker, you can prepare maybe 1 liter at a time, or put a few equipment, whatever you want. Or if not, also you can do 2 times. Do the equipment, all the equipments are sterilized once, then again the media separately. So that way you can do it. Laminar flow is a cabin, so to say, where there's two type of special filters fit inside that. Then what happens is that as I said, the cabin is a closed hole, it's enclosed. Inside that, UV ultraviolet light also is fitted. Here, this is in our country, we fit that in all our laminar floors. I have seen it is fitted with ultraviolet light. But in Western countries or this thing, I've seen they never use ultraviolet light. They just only that airflow which they whenever a person start using, they use that only pure air which comes out. So what happens is that the air goes from here. This is the coarse filter, we call it. From here, the filter will filter out all the dust particles and all those big ones, dusty one. Then it comes up here. This is called the HEPA filter inside here. Here, this is the size of the filter is pore is like 3 microns like that. So in this, it filters out all those which is not filtered out by the first filter. The second filter filter out all those things. So even the bacteria, spores, fungi, all those filtered out. So that is how you get here free flow of air current coming like that, and that is it is coming at a speed of like 27 plus minus to 3 meters per second like that. So it's very high speed. So nothing can go in from this side because of the air current coming from that side. So you maintain this in this environment free, or you call it aseptic environment inside here, and you do the work here. We keep all this equipment, whatever you wanted to use it for that inside, and then you close it. This it is then this ultraviolet light is on and kept here. This is kept for about 1 hour. It is advisable for about 1 hour. So after keeping that, when you come to work, before you come to work, you off the UV light, you can on the fluorescent light, but you have to still keep the this blower on. So this way it works. So let it be for about 15 to 20 minutes. Let it you on the blower and keep it like that. So then after that only you come and sit down and work.
This is a spirit lamp, and these instruments are soaked in alcohol. Sometimes alcohol might catch fire, but do not panic. Just cover the bottle with a lid. That will extinguish the fire. This is the seedling of rhododendron. This can be cut into many nodes. Each node is called an explant. It is cut just above the axis of the leaves. This process is called nodal culture. All the equipments and the flask should be sterilized with the help of a spirit lamp. This is a culture room. Plants of different species are grown here.
We're having different species: orchids, nepenthes, cassiana, rhododendrons, lily. Then this we have some medicinal plants. So this is depend on our project or depend on our action plan in the department. We're working on that. And these orchids are mainly for conservation purpose. We're working on multiplication of rare endangered like that.
The temperature inside the culture room is constantly checked. In this case, it is 25 degrees Celsius and the humidity is about 70%. Normally, the humidity is kept between 60 and 70%.
We germinate the seeds like this in this fuss. This when they start germinating like this comes like this. The next stage is like this. Here we thin it out. We take it out this and put into test tubes like this to let it grow faster. Now once this stage is reached, again that multiplication start like by nodal culture. We cut into pieces and this it is done like that.
This orchid is ready to be transferred to the pot. Depending on the species, some plants are straightaway planted in the pot, but others need special attention.
Some plants may, yes, they are very delicate. What happens is that when you take out from the culture that flask, it is a inside controlled environment. Here what happens is that the leaves especially, they don't develop proper the stomata, the epicotyle, so they say, this epidermis layer is not properly formed. That's why many of these stomatas are deformed. And then what happens inside the flask, inside the culture, there you are provided everything artificially. So even the plant is not doing the work of photosynthesis by itself. It is depending on that nutrient much. So that's why when you take out from lab to land, the plants are normally at the first stage weak. Then slowly they get acclimatized to, and then the leaf also start forming normal stomata or this thing. Then it start functioning itself, that photosynthesis or like that. Of course, they are also doing their part in that inside culture or room also, but still then they are not as normal plant.
Nowadays, high-tech greenhouses have all the facilities to grow different species under differently controlled conditions, which increases the survival rate of plants. Today, propagation of plants by tissue culture is gaining popularity, both for research and commercial usage. It has become popular because it can be done even in a small space and with the help of simple equipments.
If a person is really interested, he can learn it easily. He need not be very good in theoretical or this thing. But what I should say is that if whoever wants to do should have patience and should have the willingness to wait for a few years to get the result.